Okay, everyone, today's lecture is Chapter 5, Probability. Okay, let's start. Okay, so we will approach the statistics based on the mathematical theory. So statistics and probability is very highly closely related. So all the statistics are based on the probability theory. So today we will discuss the basic concept of mathematical thing named probability theory, and we will apply this probability theory for the statistics in future. Okay, so to start the theory of probability, we have to define the space where we are play on. So first, all the probabilities are based on the random experiment. So random experiment is many events which can be observed. So an observational process whose result cannot be known, it is random in advance. For example, when the customer enters a Lexus dealership, will the customer buy a car or not? Or how much will the customer spend? So these kind of things are very random, so nobody knows futures. In this case, we say that it is random experiment. So if we observe some result from the random experiment, then we gathering that result into one set, and this set is called sample space. Again, the set of all possible outcome of the random experiment is the sample space for the experiment. So we have random experiment, and all the outcomes came from this experiment is called sample space. For example, so sample space can be enumerated easily, or it is impossible to enumerate because it is so huge, or it is so continuous data. For example, so when the Citibank make the customer's loan, so we might define the sample space with only two outcomes, default, not default. Okay, so then we have two outcomes, and it is one good sample space. Or the sample space describing a Walmart customer's payment method might have four outcomes: cash, debit, credit, check. So then this set is also very well defined sample space. Or if you rolling a dice, then we have 6 outcomes. So 1 eye, 2 eyes, 3 eyes, 4 eyes, 5, 6 eyes. So then that is also very good sample space. So if you rolling 2 dice, then our sample space is like that, because 1 1 or 1 2 or 1 3 or 2 2 or 3 6, something like that. So it is also good sample space. Okay. So it is sometimes the sample space can be enumerated. So for example, 12-digit UPC barcode is on the local Walmart could have 1 trillion value. It is so huge, so it is sometimes it is impossible to show all the possible outcomes in one paper. Or so if the experiment is continuous, experiment is continuous. Continuous measurement. We've studied continuous measurement, discrete measurement in chapter 2. In this case, it is not possible to describe as list or enumeration. For example, so the sample space can be given by the length of randomly chosen cellular phone core. Okay, so if you have a phone call for 1 minute, or so you can continue the phone call for 30 minutes or 30 minutes 2 seconds point, something like that. Then this cellular phone call can have the positive number, but it is not so listed on the limited list. Or students, so average GPA can be between 0.00 to 4.00, some value between these two. Or the discrete measurement also described by rule. For example, so sample space for the number of hits on the YouTube website is given by this notation. So in this case, it is described by rule. Okay, so we have random experiment, and from the random experiment we obtain the sample space. Space is a set of outcomes, and so we have to define event. Event is mathematically, it is a function from the it is the not function, it is the subset of space. So any subset of outcomes can be event. So space itself, so space, usually space, so random, the probability space is usually given by this notation omega. So event can be the total omega, or event can be empty set, or event can be the part of the space. So because event is so simple, it is just a subset. So, but there is a more simple event. So a simple event or elementary event is a single outcome. So for example, so in this case, single outcome is just this one-eyed outcome. Single outcome is, for example, three-eyed outcome. They are single event. So single event is the subset which has only one element. Subset of space which has only one element, then we say that it is simple event. And if we have the discrete sample space. Discrete sample space means that we have finite number of elements in S, and they are countable. Then we say that it is discrete sample. So if a sample space is discrete, then a sample space can be divided by the finite number of simple event. For example, if we rolling a die, and we have sample outcomes like this. So we have 6 outcomes if we roll a die. So then we have 6 outcomes. Then simple event is, first simple event is this one, and the second simple event is this one, and so on. And the sixth simple event is this six-eyed outcome. So the sample space can be decomposed by the finite simple events. Okay. For example, it is an example of an event tossing a balanced coin. If you toss one coin, then you may have heads or tails. Okay? The possible outcome is head or tail. Okay? And okay, yeah, this event can be applied for the win or lose. Yeah. If you have a head, then you will win, and if you have tail, then you will lose. Then it can be, so the sample space can be given by win and lose. And the example of simple event is that Amazon's website, book and music. So then this website can be categorized that this books, DVD, VHS, magazine, newspaper, music, textbook. So in this case, S. So these books are one single event, DVD is one single event, something like that. And compound event, it is not simple event, just a general event of electronic media is one subset. Music, DVD, VHS is one subset of this sample space. So then this A is one event. Newspaper, magazine is another periodical print category, so subset. So in this case, B is also a good event of S. So it is very simple. Events are subset of space, and one event has only one element, then we say that it is simple event. And if it has more than one events are included in sample, then we say that it is compound event. So probability, it is important. So because all the statistics are based on the probability. Probability is, mathematical definition of probability is a function from event to number between 0 to 1. So P is a function from the event to number between 0 and 1. It is closed interval of between 0 and 1. So we have an event in sample space, then it is mapped to some number between 0, 1. Okay, so probability of A is a real number between 0 and 1. Okay, if probability is 0, then that means the event cannot occur. Okay, if probability 1, then it means that event is always certain to occur. Okay, so if probability 1, then the event will definitely happen, and probability 0, then the event will not happen in future. So simple events, so we have, if the sample space can be decomposed by simple events, E1, E2, and so on, and En, then the sum of sample events, probability of simple events, probability of simple events, sum of all probability of simple events become 1. It is the same as probability of S. probability of S is always 1. Okay? So for example, in Walmart example, customers 32% of the customers are using credit card, and 15% using debit card, and 35% using cash, and 18% using check. Then the probability of credit card is 0.32, probability of debit card 0.15, probability of cash 0.35, probability of check 0.18, and sum them up, then it becomes 1. So probability can be explained by these three methods. One is empirical, and the other is classical, and the third is subjective. So empirically, so probability is, for example, there is 2% chance of twins in the randomly chosen birth. So this 2% came from the historical research. So doctors count the case of twins among all the case of birth, and then they so find that the 2% chance of twins. Classical way is that, for example, so without the empirical research, we know the priori knowledge by nature. For example, so if you do the tossing coin, then you may agree that 50% chance of head. So in this case, we need not to check the empirical test, but we know that the probability of head is so 1 second. Okay. And subjective is that it is the gambler's probability. So there is the 75% chance that England will adopt the euro currency by 2012. So of course it is so old, but so if you were 2010, so and finally we realized that so England does not accept the euro currency. Anyway, so gamblers just so believe that 75% when they were in 2000. Okay, in this case, it is very subjective approach. Okay, so then there are many rules for the probability function, so we will check the probability one by one. So event A is a subset of space, sample space, and complement of event A is denoted by A prime. So if we have a sample space in here, and here is event A, then so the other so element outside of event A is A prime, complement of A. So they are all the complement of A. So if A prime is an element in the sample space such that so X is not in A, so then we say that it is complement. So A and A prime are, so here is sample space, then this part is A, then the other part is A prime. So the probability of A prime and probability of A and probability of A prime are so mutually disjoint, and the sum of them is always 1, because A prime union A is S, so we always have this property. So we just change the equation. So this one go to this place, then we take the minus sign. So then we obtain this equation. The probability of A complement is 1 minus probability of A. For example, probability of survival is equal to 1 minus probability to failure. Okay? The probability of failure is 0.33. then the probability of survival is 0.67. Union. Union is that if we have two events, event A and event B, then union is an event such that A or B. So if one event is included in A, then it is included in A or B. It is included in B, then it is included in A or B. And some event can included in A and B both, then it is also included in A or B. So this diagram is easy to understand. If you study the set theory, then you can find what it, you may know that the meaning of this diagram, Venn diagram. So it is A or B. So, or simply we denote it as A union B. So symbol U is read or union. Okay, for example, so you are playing with a trump, so trump cards. So, and trump cards has 52 cards, 52 cards, and 13 is included in spade, and 13 is included in diamond, and 13 is included in crowbar, and 13 is included in heart. And so this 13 means that 1, 2, 3, 4, 5. So this 13 is 1 is ace, 2, 3, 4, and so on. And 10 and 11, instead of 11, we say that junior. And instead of 12, we say that it is queen. Instead of 13, we say this card, the name of this card is king. So here is that if Q is the event that we draw a queen, and that means this one, and R is the event that we draw a red card. So then Q union R is that we draw a queen or red. So these two the diamond and so heart is red cards, and these two spade and the crowbar is black. So if we draw one card and it is Q or R, then we have 4 possibilities in 52. So the probability of that we have a queen is the 4 possibilities in 52, and the probability of red card is that 26 probabilities. So in 52 cards. And if we have the both queen and red, so queen and red is only 2 possibilities in 52. Okay. So that is the meaning of union. And intersection. So intersection is that if an event is included in event A and at the same time it is included in event B, then we say that it is A and B intersection. And using Venn diagram, we say that the middle part is the intersection part. For example, if we have queen card event, and so Q is draw a king card, and R is event we draw a red card, then Q intersection R is the event that we get card that is both queen and red. Okay? So in this case, queen heart or queen diamond is the match to this condition. So we have only 2 possible outcome to get queen and red. Okay. So general rule of addition, I always give this problem in the exam, then only 50% just solve this problem correctly. Okay, so the probability that A union B, A or B, probability of A or B is same as probability of A plus probability of B minus probability of A intersection B. That is the general rule of addition. Because if we add probability A, probability B, then the intersection part is added 2 times. So here is intersection, that is A, plus here is intersection B. Then if we add them, then we have this part and this part and this intersection part 2 times. Okay, so here, so this part is matched to this part and this part is here. So if we add probability of A and probability of B, then the intersection part is added, duplicated. But we need only one, so that should be gone. So probability of A plus probability of B minus probability of A intersection B, so that is this part. Then we obtain this correct answer, probability A union B. So for example, we have queen card. The probability that we have queen card is that 4 given 54 over 52. And probability that we have red card is that 26 over 52. So the probability that queen and red is 2 over 52. So then probability that queen or red is that the 4 over 52 plus 26 over 52 minus 2 over 52, and finally we have this probability. Okay, so it is it is the same as we studied in here. We have 26 possible possibilities and 2 possibilities. It is 28. Okay, so 28. And mutually exclusive event is that 2 events A and B are mutually exclusive if their intersection is empty. So if the intersection is empty, A and B has no common part, then the probability that A intersection B is always 0, because probability of empty set is always 0. So that is always 0. So probability that A intersection B is 0, then we say that A and B are mutually exclusive. So in Venn diagram, we have this figure. A and B. If we describe this event by Venn diagram, then so here is A, here is B, and this 2 set has no intersection. Okay, and they have some distance. Okay. Okay, for example, event A is the Applebee's customers finishes her lunch in less than 30 minutes. And B is the event that she take 30 minutes or more. So then event A and event B cannot have some intersection. So intersection is empty. So nobody can finish their lunch less than 30 minutes, and at the same time they take more than 30 minutes. So it is nonsense. So the intersection is 0. And so customer's age, event A is customer's age is under 21, and event B is customer's age is over 65 or something like that. So then we say that they are mutually exclusive. But here, these examples are not mutually exclusive. For example, student's major is marketing, and B is the event that the student has the economics major. So some student has marketing major and at the same time economics major. So in this case, A and B are not mutually disjoint. And somebody has the Bank of America bank account, and another event is that so somebody has the JP Morgan bank account. So then many people has the account in both of this bank. So these two events cannot have a mutually disjoint. And the third is also so Visa, Master, and American Express. Somebody has the Visa card and at the same time American Express and Master, or sometimes some guy may have only the Visa card, but so they cannot be so mutually disjoint. So if A and B are mutually exclusive events, then the intersection is 0. So then let's apply the general law of addition. So A union B is A plus probability of A plus probability of B minus probability A intersection B. So probability A union B is probability of A plus probability of B minus probability of A intersection B. But A and B are mutually exclusive events, then probability of intersection A and B, this part, is 0. So we ignore this part, and finally we obtain that A and B are mutually disjoint, mutually exclusive. Then we say the probability of A intersection B, A union B is probability of A plus probability of B. We look at a person's age. So then probability that under 21, probability that over 65 is 28% and 12%. Then probability that under 21 or over 65 is 0.28 plus 0.12, and we have 0.40 because these two events are mutually exclusive. Okay. Collectively exhaustive events are like this. These events are so collectively exhaustive if their union is entire sample space. So the events are all mutually exclusive, and union of them is the same as total sample space. Then we say that they are collectively exhaustive. For example, we have so A is a car repairs either covered by the warranty is A, not covered by warranty is A prime. So A and A prime are complement. So then A intersection A prime is empty, And at the same time, A union A prime is the total space. In this case, A and B are so collectively exhaustive events. Another example is that here. So a Walmart customer can pay by credit card A, debit card B, cash C, check D. So then nobody can use the credit card and debit card at the same time. So A intersection B is empty. A intersection C is empty. A intersection D is empty. B intersection C is empty. So B intersection D is empty. C intersection D is empty. And so they are all mutually exclusive. And they are all mutually exclusive. And union of them, A union B union C union D, is total sample space. In this case, we say that this A, B, C, D are collectively exhaustive events. So mutually exclusive, and the union of them is the sample space itself. Then we say that this group of events are mutually exclusive. Okay, conditional probability is also a very important notion. Conditional probability A given B, we read this probability as the probability of A given B is defined by this equation. So probability A intersection B over probability of B. So if probability of B is positive, so if probability of B is 0, then the conditional probability is not exist. So we exclude this case. So probability of B should be always strictly bigger than 0. Okay, so if this condition is not correct, then we cannot divide it by probability of B. So somebody says that if probability of B is negative, then what will happen? So then, but it is impossible, because probability is always between 0 and 1. So probability can have 0, but probability cannot have negative. Okay? But probability of B is 0, then this definition is not well defined. So we only consider that probability of B is positive. Anyway, so conditional probability is given by this equation. So if we draw it with Venn diagram, then probability of A given B is that. So here, this probability, this part, set of B is their universe. So sample space, if that is bigger sample space, but sample space is restricted to B. So if the sample space is, so we exclude all other cases and we only concentrate probability of B. So it is our new universe. Under this sample space, the probability of A. So then this part is excluded. Only this part is for the probability of A. So probability of A intersection B is meaningful for our in the conditional probability, and it should be divided by probability of B, because we will not use S but use B. So anyway, so this conditional probability is given by this equation. Okay. For example, high school dropout. So, of the population aged 16 to 21, young guys, and not in college, 13.50% are unemployed, 29.05% are high school dropouts, 5.32% are employed high school dropouts. So then, what is the conditional probability that a member of this population is unemployed given that the person is a high school dropout? Okay, so that is the question. So let's analyze this problem one by one. U is, let's define U, event U is the event that the person is unemployed. Okay, and D is the event that person is a high school dropout. He is included in the high school dropout. So then probability of unemployed is 0.1350 because here we have that 13.50% are unemployed. Probability of D, so high school dropout, is 2905 because 29.05% are high school dropouts. And probability that U intersection D is 0.0532 because 5.32% are unemployed and high school dropouts. So our question is that given the person is high school dropout, it is the condition, what is the probability that the probability of this member is unemployed? So then, probability of unemployed given dropouts, high school dropouts, it is equal to probability that U intersection D divided by probability of D, okay, based on the definition of conditional probability. So then this probability of U intersection D is here. Probability of D is here. So we have 0.0532 over 0.2905 and 0.1831. That is conditional probability of unemployment given dropout, high school dropouts. Yes. So then probability of unemployed given high school dropout is higher than the general unemployed probability. So then we conclude that high school dropout event so increase the percentage of unemployment. Okay. Independent event. So if two events are not affect each other, so event A does not occur any effect to the probability A, and vice versa, probability A does not give any effect on the probability B, then we say that A and B are independent. But this sentence is not mathematically clear. So so mathematicians use this definition. If the conditional probability A given B is the same as the unconditional probability of A. So probability of A given B is the same as probability of A. So then this probability B does not give any effect on A, then these two events will have the same probability. In this case, we say that A and B are independent. So if the probability of event A is the same, whether event B occurs or not, then we say that it is independent. For example, text messaging among the high school students is independent of the gender. Okay? This means that whether the student is male or female does not change the probability of the student use the text message. So event A and B are independent, then we say that. So if this equation is true, then A and B are independent. Okay. So then probability of A given B is probability of A intersection B divided by probability of B. But A and B are independent, then this probability A given B is probability of A. It is the same if they are independent. So finally, we obtain that probability A given A intersection B divided by probability of B is same as probability of A. So from this equation, we have this result. And finally, we obtain that probability of A intersection B is probability of A times probability of B. So we obtain this result. So we can say that if event A and B are independent, then probability of A intersection B is the same as probability of A times probability of B. Okay? So if we want to check that probability A and probability B are, whether probability of A and probability of event A and event B are independent or not, then you just check this equation, then that's it. For example, Noodle and Company restaurant have the waiters have some question. If the customer order a dessert, so we denote it as event D, with male is probability 0.08. And the probability that customer will order a buttered beverage is event B is 0.14. Okay? So then the waiters are curious that this event D, so dessert, and event B, buttered beverage, are independent. Is ordering dessert independent of the ordering buttered beverage? That is the question. To know the truth of this question, so we have to check that probability of D is 0.08 and probability of B is 0.14, and the joint probability that customer will order both dessert and buttered beverage is 0.0112. So probability that D intersection B is 0.0112. Then, okay, probability D times probability B is 0.08 times 0.14, and it is 0.0112, and it is the same as probability that D intersection B. Okay? So we saw this fact. That means probably the event D and event B are independent of each other. So customers has ordered a buttered beverage does not have any information that they will order the dessert. Okay? These two events are independent. So if I ask you in the exam, these two events are independent or not, then you have to check this equation, and if this equation is true, then you can say that these two events are independent. And if this equation is not true, then you say that these two events are not independent. Another example is television ads advertisement. So for example, let's consider that Super Bowl. Target audience is 2 million viewers. Advertisement A reaches 500,000 viewers, and B reaches 300,000 viewers. And both ads reaches 100,000 viewers. So that is probability of A is 0.25, probability of B is 0.15, and probability of A intersection B is 0.05. So, and conditional probability A given B is that, so same as this equation as we studied in the conditional probability. So then we apply this value and this value in here, and then we obtain the 0.3333. So the conditional probability A given B is 0.3333. Okay, and the probability of A is 0.25, so we can say that probability that A given B is not same as probability of A. So that means probability A and probability B are not independent. Not independent. On the other hand, alternatively, probability A times probability B is probability A is here, probability B is here, is 0.0375, and probability A intersection B is 0.05. So probability of A times probability of B is not same as probability A intersection B. So that means probability A and probability B, so event A and event B are not independent. Okay? If I asking you that these two events are independent or not, then you have to check this fact or this fact, and you have to conclude this. Okay? And we can apply this independentness to n different events. So if first event, second, and nth event are all independent, then we can say the probability of A intersection B intersection C A1 intersection A2 intersection blah 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 AN is the same as probability of A1 times probability of A2 blah 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 and probability of AN. Then we say that they are all independent. It can be used for study the stochastic calculus or time series model, but it is a little difficult. Okay, let me finish here, and I will continue the chapter 5 in next video.